Welcome back to Miles Reads. I'm Miles. Today, I'll be breaking down the book The Victory of the Seeds. How grains, nuts, kernels, pulses, and pips conquered the plant kingdom and shaped human history. The core idea I'll explore is how seeds came to dominate the terrestrial world and, in doing so, profoundly shaped the development of human civilization. In the natural world, over 90% of all plant species reproduce using seeds. Nearly every plant we see daily, from fruits and staple grains like wheat to all kinds of beans, is a seed plant. But despite their ubiquity today, other types of plants once ruled the earth for over 100 million years. So, what unique advantages do seeds possess that allowed them to triumph in the long course of evolution? Nature is a complex system where all members influence one another. The rise of seed plants inevitably impacted other organisms, especially humans. In a sense, it was seeds that molded human history. This book reveals how seeds won the game of natural selection and went on to influence every facet of human life. We have a saying, "You reap what you sow," which not only speaks to the value of hard work, but also captures the profound sense of reliability we place in seeds. Just sow a seed, and you can expect a future harvest. This dependable certainty has massively eased humanity's anxiety about starvation. In the early days of civilization, the stable expectation of fruit and grain gave rise to agriculture, allowing humans to leave behind the precarious, nomadic life of hunting and gathering. The reliability of seeds not only enabled plants to reproduce with incredible efficiency, but also provided humanity with abundant resources, completely transforming our way of life and pushing civilization steadily forward. Today, we live in a world surrounded by seeds. From the bread and coffee that sustain us, to the cotton in our clothes, to the industrial alcohol and dyes used in manufacturing, we derive an incredible variety of energy and materials from seeds. But have you ever stopped to wonder why seeds have had such a revolutionary impact on human life? The answer lies in the very characteristics we often take for granted or overlook: their nutrition, their self-defense mechanisms, and their strategies for dispersal. The book's author, Thor Hansen, is a renowned biologist, conservationist, and brilliant science writer who has received the highest honor in American nature writing, the John Burroughs Medal. With that introduction, I will now delve into the three core concepts of the book. First, the nutrition of seeds. What kind of provisions do plants pack for their seeds? And how did this nutrition impact human civilization? Second, the defense of seeds. How do seed plants protect their offspring? And how did their defensive measures change human life? Third, the dispersal of seeds. What inspiration and resources has humanity drawn from the diverse ways seeds spread? Let us take them one by one. First, let's focus on nutrition. What provisions do plants prepare for their seeds, and how has this influenced human civilization? For the average person, a seed can be thought of as a plant's baby. This baby comes with two essential items: a nutrient-packed lunchbox and a tough, protective case. Different seeds have different contents in their lunchboxes. Some are rich in starch, while others are packed with protein. The plant bundles its baby and its provisions together, much like a baby in a stroller with a bottle. The benefits of this packaged strategy are obvious. It allows for rapid movement, helping the seed travel far and wide. The protective case offers effective defense, while the built-in food supply ensures the baby has enough nutrition in its early stages without being overly dependent on the external environment. Take the avocado, for example. It grows in dense rainforests where seedlings struggle to get sunlight. The rich nutrients provided by the parent plant become critical for survival. This nutritional package, like baby formula, provides essential energy before the plant can sustain itself. The provisions an avocado prepares for its offspring are incredibly lavish, including proteins, fats, and starches enough to support the seed for months or even years after it sprouts. It's the trust fund baby of the plant world. Of course, such a massive investment means that an avocado tree cannot produce a large number of seeds. Its resources are finite. Unlike the avocado, plants in open plains have seedlings that can quickly access sunlight and begin photosynthesis. Therefore, for grasses, the best strategy is to produce in quantity, spreading limited resources across many offspring to achieve rapid propagation. Our ancestors discovered the nutritional wealth of seeds early on. Before the advent of agriculture, humans were already extracting energy from roasted seeds. To this day, chimpanzees will forage for roasted seeds after a forest fire. Archaeological finds show that over 20,000 years ago, humans were using stone tools to grind wild barley, and over 100,000 years ago, similar methods were used to process sorghum into food. Regardless of when new discoveries push back the timeline, one thing is clear. When humans settled down to practice agriculture, grass seeds like wheat and barley naturally became our staple foods. Although people ate grass seeds before farming, the variety they consumed actually decreased with the dawn of the agricultural age. People selected a few types of grains suited to their local environment for intensive cultivation, a trend seen in agricultural revolutions worldwide. The chosen few were mostly annual plants. A shorter life cycle means the plant pours all its available resources into reproduction, rather than into growing leaves and stems. That's why most of the crops we see in fields today are annuals. People also discovered that different seeds contain different nutrients. Wheat is primarily starch, cocoa beans are rich in cocoa butter, and many legume seeds contain large amounts of protein. While this nutritional diversity is beneficial for humans, why did plants evolve such varied ways of storing nutrients? One of the most perplexing is the oil in seeds. Weight for weight, oil provides more energy, which is clearly advantageous for plants in dense forests. In environments with scarce sunlight, the more energy a seed carries, the greater its chance of survival, which is why forest seeds tend to have higher oil content. But many plants that grow in open plains, like rapeseed, also pack their seeds with oil. Why is that? The author suggests our confusion stems from a misconception. We assume that existing forms of nutrient storage are the optimal solution. In reality, many storage methods were eliminated during evolution. Those that remain are adapted to the current environment, but that doesn't make them the best strategy, only that they meet the minimum requirements for survival. Evolution is a never-ending process, and these nutrient storage methods may well change in the future. The author also notes that seed nutrition has profoundly affected our lives in unexpected ways. Today, we can get all kinds of grains in most parts of the world, but in an age of less developed agricultural technology, people were at the mercy of the elements. Some regions, like parts of Africa and the Americas, were not well suited for growing grain. Others, like the Mediterranean coast, enjoyed a unique natural environment that gave rise to more competitive early civilizations. Later, as grains became a dietary staple worldwide, any change related to them was bound to have widespread social repercussions. For instance, grain prices have a huge impact on social stability. In the late Roman Republic, leaders pacified the populace by distributing free grain or providing subsidies, a key political tool at the time. Even today, soaring food prices can threaten social stability, and many countries still have similar price intervention measures. Grain trade even spread disease. The spread of the Black Death in the 14th century was closely linked to the grain trade. At first, people blamed earthquakes or miasma, but epidemiologists later discovered the source was a small flea living in the fur of black rats. Even so, that couldn't explain how the plague spread so widely, as a rat's range is typically only a few hundred meters. It wasn't until much later that people realized the key wasn't the rat's range, but their diet. Rats live where grain is plentiful. Coincidentally, the larvae of the fleas that carried the virus could also feed on grain. Thus, when grain, a major trade commodity, was transported by ship to various ports, the rats and fleas hitched a ride, spreading the plague. Consequently, the areas hit hardest by the Black Death were the port cities with the most active grain trade. Only isolated nations were spared. In short, grain is so deeply embedded in human society that any change related to the grain itself or its commerce inevitably affects all other aspects of society. That covers our first key point. To summarize, plants in different environments prepare different qualities and quantities of nutrients for their offspring. Because seeds are so nutritious, humans gradually made grains their staple food. Grains, in turn, have influenced humanity in unexpected ways, serving as political tools through food subsidies and as vectors for the Black Death via trade routes. Next, let's explore the second part, the defense of seeds. How do seed plants protect their offspring, and how have their defenses changed human life? As we mentioned, seed plants package their baby and its food into a box. And this box is itself a form of defense. A seed's hard coat can ward off attacks from insects or small animals. But beyond physical defense, seeds also possess a powerful chemical arsenal. One of these chemical weapons gives us the unique sensory experience of spiciness. Hot flavor is crucial to us. Without it, countless restaurants specializing in spicy cuisine would go out of business. Chemically, this heat comes from capsaicin. You might be surprised to learn that the ancestors of chili peppers weren't spicy at all. They evolved capsaicin primarily to defend their seeds against fungal attacks. Fungi can kill most of the seeds they infect, but capsaicin effectively slows their growth. In the course of evolution, chili peppers and fungi engaged in an arms race. As fungi evolved stronger resistance, the peppers produced more capsaicin to fight back. Of course, this race wasn't endless, as evolution comes at a cost. For the fungus, stronger resistance meant slower growth. While high resistance helped it infect chili seeds, the trade-off in growth speed could be a fatal disadvantage in other environments. For the chili pepper, producing capsaicin affects its ability to retain water, potentially reducing seed yield in dry weather. Furthermore, peppers also had to contend with ants. Too much capsaicin makes the seed coat more fragile and vulnerable to ant attacks. Based on how capsaicin works, we can deduce that peppers are generally spicier in places with abundant rainfall, as humid conditions are more conducive to mold. In arid regions where fungi don't thrive, peppers don't need to waste energy producing capsaicin. In the past, besides seeking a thrill, people used chili peppers for another important purpose. As a food preservative, capsaicin deters not only fungi but many other microbes as well. However, not everyone used peppers this way. In the Columbian era, spices like chili were luxury items. Those who could afford them could also afford fresh food. When Columbus set sail, he received substantial backing from royalty and nobility, all eager for exotic spices from faraway lands. Fortunately, once seeds were transported across oceans, people discovered that as long as the environment was suitable, they could be grown anywhere. This led to the mass cultivation of chili peppers and other spices, causing their prices to plummet and bringing them into the kitchens of ordinary people. Besides capsaicin, another widely used chemical weapon is caffeine. We all know caffeine is a stimulant, but you might not know it's also a natural insecticide. And it's not just coffee plants. Cocoa, cola nuts, and several other plants produce caffeine. So how do plants use caffeine to repel insects? When we cultivate plants, we often apply nitrogen fertilizer, showing how vital nitrogen is for them. Producing caffeine consumes a great deal of nitrogen. Coffee trees in the wild can't fertilize themselves, so to save resources, they've learned to recycle caffeine. First, they send it to tender young leaves to fend off pests like snails. As the leaves mature and harden, the tree transfers the caffeine from the leaves to its flowers, fruits, and seeds. The seeds not only receive caffeine from other parts of the plant but also produce some themselves, building up a high concentration to repel attackers and ensure their own survival. However, caffeine is a double-edged sword for the plant. It not only repels insects but can also inhibit the seed's own growth. To germinate successfully, a coffee seed must rapidly absorb water, allowing its cells to swell and push the root and shoot outwards, away from the high concentration of caffeine. As the seedling grows, caffeine leaches into the surrounding soil, where it transforms into an herbicide, inhibiting the growth of other plants. Caffeine's role doesn't stop there. In the right dose, it can also attract bees to help with pollination. Bees show a preference for flowers whose nectar contains caffeine, much like office workers lining up at a coffee shop. Speaking of coffee, the popularity of this beverage has had a profound impact on human society. The rise of the coffee house, unlike the tavern, created a space not for revelry but for conversation, meetings, and even business deals. The Bank of New York was founded in a merchant coffee house, and the London Stock Exchange grew out of one. Public sales held in coffee houses eventually led to the creation of the world-famous auction house, Christie's. Philosophers, writers, and other intellectuals also flocked to coffee houses to exchange ideas. Some even called these elite hubs penny universities, because for the price of a cup of coffee, one could listen to the insights of brilliant minds. Moreover, many politicians frequented coffee houses, and in some regions, revolutions were closely tied to them, with people using them to make plans, seek refuge, or even as makeshift hospitals. In short, just as caffeine attracts bees, coffee houses attract people. And where people gather, business gets done, ideas are exchanged, and even revolutions can be sparked. That covers our second key point. To summarize, a seed's hard shell provides physical defense, while chemical weapons like capsaicin and caffeine fend off other threats. Capsaicin not only provides a pleasant sensory kick, but was also an important food preservative. With the age of discovery and global cultivation, spices like chili went from luxuries to everyday ingredients. Caffeine is used by plants as an insecticide and herbicide, while also attracting pollinators. In human society, the coffee culture that formed around the beverage gave rise to coffee houses, which became vital incubators for commerce, ideas, and political movements. Next, let's explore the third topic, the dispersal of seeds. What has humanity learned and gained from the diverse ways seeds spread? Many people think spreading seeds is as simple as tossing them on the ground. In reality, it's far more complex. For instance, a seed can't be too close to its parent plant, or it will have to compete with a much stronger adult for nutrients, with little chance of success. So, how do you get the seed farther away? The most common method is to use animals. This service isn't free. Of course, the sweet pulp surrounding the seed is the plant's payment. In the Americas, one species of bat feeds on the fruit of the kummeru tree. The bats carry the fruit away, fly to a safe spot to eat the flesh, and then discard the seed. In this way, the kummeru tree seeds are successfully dispersed. You might ask, why don't the bats just eat in the tree? Wouldn't flying with the fruit be more tiring? Actually, the bats have no choice. The area around the kummeru tree is frequented not only by fruit-loving bats but also by bat-loving pythons and large birds. If the bat doesn't take the fruit and run, it might become dinner itself. Besides partnering with animals that only eat the fruit pulp, plants also take huge risks by collaborating with seed eaters like squirrels, rats, and other rodents. These animals, also trying to avoid becoming a predator's meal, will carry seeds elsewhere before eating them. But if they eat the seed, isn't the plant's effort wasted? Fortunately, there's a good chance these animals will be killed by another predator before they can eat the seed, allowing it to survive. Of course, plants don't rely entirely on luck. The seed's thick shell comes into play here. A hard shell increases the time it takes for an animal like a squirrel to process the seed. The longer it takes them to crack it open, the greater the chance the seed will survive. Now you might understand why walnuts are so hard to crack. Among the many collaborators that help spread seeds, the most efficient might just be us humans. To put it dramatically, humans have, to some extent, become the plant's servants. We toil to carry their seeds all over the world, building orchards and farms for them, providing fresh water and fertilizer. In essence, this is all part of the same seed dispersal process as a bat eating a piece of fruit. Besides using animals, plant seeds often travel by wind. The seed of the Javan cucumber, for example, has a large, thin wing that allows it to glide on the wind. Unlike a bird's wing, the seed's wing is fixed, more like a kite, and needs the right wind to take flight. Humans have even borrowed this wing design to invent unique aircraft, such as the American B-2 stealth bomber. Consider cotton. The fibers surrounding its seed not only allow it to be carried by the wind, but also let it float on water. With luck, cotton can ride strong winds and ocean currents across the sea to another island or continent. For us humans, these white fibers have played a momentous role in modern history. It was the first commodity to be mass-produced on a global scale. To process cotton more easily, people invented all sorts of machines. But while machines simplified processing, growing cotton still required a massive amount of labor. The highly profitable American cotton industry led to an unprecedented boom in the African slave market. In the 1790s, more than 80,000 slaves were trafficked to the Americas each year. Although the U.S. Congress banned the international slave trade in 1808, the domestic slave trade continued to flourish. The combination of slaves plus cotton formed the bedrock of the Southern economy before the American Civil War. Because the North and South had fundamentally different views on slavery, the slave trade laid the deep groundwork for the conflict. It's fair to say that for a long period in modern history, where there was cotton, there were the blood and tears of slaves. That was our third key point. To summarize, plants use animals to disperse their seeds, offering fruit pulp as payment. Even when dealing with animals that eat seeds, plants have strategies to ensure their survival. Humans, in pursuit of the plant's rewards, have become the most extensive dispersers and cultivators. Plants also use the wind for dispersal, with their ingenious designs even inspiring human technology. The dispersal and use of the cottonseed became deeply entangled in modern history, as its industry fueled the slave trade and indirectly shaped the American Civil War. With that, we're nearing the end of today's discussion. Let's do a final review. First, we talked about seed nutrition. Plants prepare diverse nutrients for their seeds, with those in sunny environments carrying fewer provisions and those in rainforests packing a wealth of them. These nutrients provide the essential energy for a plant's early growth. Once grains became a human staple, their price fluctuations profoundly affected social stability, and the grain trade even became a vector for the Black Death. Second, we explored seed defense. To protect their offspring, seeds evolved hard shells and a variety of chemical weapons. Capsaicin fends off fungus, while caffeine acts as both an insecticide and an herbicide. Chili and coffee have dramatically changed human life. The former became a beloved spice and preservative, while the latter gave rise to the coffeehouse, a vital space for social, commercial, and intellectual exchange. Finally, we analyzed seed dispersal. Plants attract animals with fruit to help spread their offspring, and humans, seeking the plant's rewards, have become the most efficient dispersers of all. Plants also use the wind, and their clever designs have even inspired human inventions. The dispersal and use of cotton, however, are linked to the dark history of the slave trade and war in the modern era. By understanding plants and their seeds, we see the elegance of their function, all of which stems from the long, unending process of natural evolution, a process of constant filtering and change. In a way, seeds connect the past to the future. In them, we can see the history of our changing natural environment and how they, step by step, have shaped us. That's all for today. Congratulations on finishing another book.